So this one is the same thing you were doing yesterday. 3 square root of x plus 5 equals 27. Jordan, what do you want to do first? Yep, divide by 3. So we're going to have the square root of x plus 5 equals 9. Danny, what do you want to do next? Yep, square both sides. So we always use the exponent that's the opposite, or sorry, not the opposite. We want to use the exponent that matches, rather, the index. So that's how we chose the squared. And so we get x plus 5 equals 9 squared, so 81. Subtract our 5, so x equals 76. We okay with that? Okay, let's move on to some new stuff. So now we're going to have 2 radicals. So I have the square root of 4x plus 1 equals the square root of x plus 10. When we had one radical, our goal was to get it on one side and everything else on the other. When we have 2 radicals, our goal is going to be to get them actually on opposite sides. Because if I just had this radical, what would I do to get rid of this radical? Square it. So I would think, okay, let's square this one. Well, if I square this side, what am I going to do to this side? What happens if I square this radical? Yeah, it's gone too. So when I square one side, I have to square the other. It eliminates both radicals. So that's why it's nice to have both radicals on opposite sides. As long as, what do you think has to be true? The index has to match. Well, the good news is the indexes I'm going to give you, or the book is going to give you, they're going to match. So we get them on opposite sides. We use that power that matches the index. Now they're eliminated. And now we solve. So we say 4x plus 1 equals x plus 10. Oh, maybe a little bit harder equation to solve because we got x's on both sides. That's not a big deal. We can solve equations like that. I'm going to move this x over to the left. Some of you will move the 1 at the same time. I'm going to take my time. So I'm going to say 3x plus 1 equals 10. Then I'm going to subtract my 1. Again, you could do that all at once if you wanted. 3x equals 9. Divide x equals 3. Okay, not bad. So let's say I have something like this, where they're on the same side. Cube root of 12x minus 5 minus the cube root of 8x plus 15 equals 0. Cube root of 12x minus 5 minus the cube root of 8x plus 15 equals 0. Anyone have some thoughts?
Add the 8x plus 15.
I could add this whole term. So I'm going to add the cube root of 8x plus 15. I'm going to add it over here. So then this radical stays on the left. Cube root of 12x minus 5. This is just 0 over here, so I don't need it. I now have the cube root of 8x plus 15. Well, that pretty much, almost, looks like what we just had on the last one. But instead of squaring both sides, I have to use what exponent? Cubed, or a 3. Make sure you're showing me what exponent you are using. So I am going to use an exponent of 3. So then I'm going to get 12x minus 5 equals 8x plus 15. And then you're going to take a little time to solve that. I'm going to move these x's over. So minus 8x. So 4x minus 5 equals 15. Add my 5. And again, some of you can do those steps all at once, and that's fine. I'm going to go over here a little bit. So 4x equals 20. Divide by 4. X equals 5. All right, going pretty well. Doesn't seem that much harder. Now we're going to talk about something I mentioned yesterday. Let's wait a second for that. I mentioned this thing called extraneous solutions. Well, an extraneous solution is pretty much what that word kind of looks like. It's an extra solution. So we got to put that in our notes. An extraneous solution is, for lack of a better term, an extra solution. It does not satisfy the equation when substituted back in. So you've done all your work right. But when you go and you take this answer and you plug it back in, you get a false answer, or it's not true. So that means we have to check our answers. We put that in our steps yesterday. We said at the very end of our steps, it's only 3 steps, but we put at the end, we said, oh, we have to solve and we have to check. This is why we have to check. It's not going to be that we've done something wrong. It's going to be that, oh, I did everything right, but I got this answer, and if I plug it back in, it doesn't work. So I have to cross it off. That doesn't apply to all the problems we do. All the problems may not have these extra solutions. I'm going to tell you specifically which ones might have them, which ones you have to check. The book doesn't do that for you. The book tells you have to check all of them, so I make it a little bit easier. So these next few we're going to have to check because they might have these extra solutions. So this is the first one. So it looks like the same thing we've been doing, but it may not yet. It may have one of these extra solutions, extraneous solutions. I've got the 4th root of 3x minus 5 equals the 4th root of 5x minus 8. Well, they're on opposite sides, so that starts off well. Jared, what do you think I'd do first?
You would promote the parentheses and have 4 on the outside.
As a good. So I'd use an exponent of 4, put them both in parentheses, that's good. Use an exponent of 4, raise it to the 4th power. We can say that either way. So they cancel out the radical. And when we get to this part, just a basic algebra equation, I think we're good solving. We get 3x minus 5 equals 5x minus 8. People have different ways they like to solve it. I like to get my variable on the left. So I subtract 5x. You can do it however you like. So I get negative 2x minus 5 equals negative 8. I'm going to add 5. Felt like I made a math mistake, but I didn't. So negative 2x equals negative 3. X equals 3 over 2. We're going to plug this in and see if it works. So what we're going to plug in is in our calculator. Oh, this is going to be kind of hard to plug into our calculator, so we got to be careful. So in our calculator, we have to type in 4, the caret button, second caret button to get the radical. That was my bad. So then it looks like this. I never remember, does it give us a parenthesis or not? I feel like not. Okay, so it doesn't give us a parenthesis, so we need a parenthesis. So parenthesis, 3 times 3 over 2 minus 5. That's all underneath the radical, so close the parenthesis. Hit equals. Oh, yikes. So what do you think that means? Nope, what, Taylor?
No extraneous solutions.
So it's an extraneous solution, I agree, but let's see if we can figure out why. So why is it telling us a domain error? What?
You probably know the answer.
I do, but I'm asking you. I'll tell you if you're right or not.
Because there's no solution.
Not because it's a fraction, but at least now we're thinking. Why is it no solution?
Because there's multiplication.
It's not technically no solution. When does our calculator tell us domain error? Negative where?
Oh, because the index is positive.
Getting closer.
She said it's not because of a fraction.
Index is what? Index is even. Need a little more now.
And then there's a negative.
What's?
There's a -5, so
Well, not just the -5.
plus and minus.
No? What did you say, Ridge?
Dang,
Not that it's a perfect square. Do this. Without the radical. Do 3 times 3 over 2 minus 5. Do that part. Do it without the radical. -1/2. So you're taking the 4th root of -1/2. Why?
It's a fraction.
Not because it's a fraction.
It doesn't go with that.
Nope.
It's a negative.
Because it's a negative. What happens when you take the 4th root of a negative, or the square root of a negative, or the 6th root of a negative?
It's an error.
Yes, you get an error in your calculator, but we know what it is mathematically. It's not stupid.
No solution.
What?
No solution.
It's not no solution. It's another math word we have. Starts with I.
I figured it out and I got it to work, so I did something wrong clearly.
Not irrational. Not improper. Not inconsistent.
False.
Inconceivable.
It's something we talked about a lot. Starts with an I. What? Imaginary. That's when we would get an error, right? If we would take the square root or 4th root or 6th root. If we get an error, it's imaginary. We said in this chapter we're not talking about imaginary. We only care about real answers. So yes, the bottom line is we're saying it's extraneous because it's not real. But we also like to, oh, guess what's coming up? Your exam. Your exam is right around the corner. Guess what's on your exam? Imaginary numbers. So we kind of want to keep that a little fresh in your mind. Okay, so yes, we're going to do this. We're going to cross it off. That's all you would have to do on your homework. But let's put a little bit of something in our notes. So let's just put for our notes that this is extraneous because it's imaginary.
Yo, I'm not gonna lie, when she said it starts with an I, part of me wanted to say isosceles, but then I realized it's geometry. I was like,
At least
I'm
it
not
started
gonna-
with an I and not like an E or something. And you may even want to put an error in your calculator. So you remember if you get an error in your calculator, that's going to tell you to put, extraneous, or you put a line through your answer on your calculator.
What if it's not? Like what if it actually plugs in?
So that's a good question. So if it plugs in, let's say you got 2.7. Let's say that's what came up on your calculator. So if that comes up on your calculator, what do you think you do next? Well, you could put it into a fraction, but good news. You don't have to put it into a fraction. I know that's what we're in the habit of doing.
That was your answer?
That's not your answer. This is our answer. This is our X. This is our check. So we're checking and we're saying, okay, this side is 2.7. I got to make sure this side is 2.7. So I would have had to check this side. So we might see that in the future here. So let's try another problem. I know. So much work I give you. This is another one we're gonna have to check. This one I've got x plus 1 equals the square root of 7x plus 15. Oh, this is different. That one was not me.
Yeah, that one was not.
Okay. X plus 1 equals the square root of 7x plus 15. So this one has some stuff outside the radical and some stuff inside the radical. Well, the radical's by itself on one side. So what do you think I do to get rid of the radical? Square it. So I'm going to square this. I like to call it an exponent. And so I got to square this whole side.
I knew what it was.
So I got to square the whole other side. Oh, look what that looks like. X plus 1 squared.
I already wrote down everything else, I forgot to.
Not factor, but the other. Yeah, I was going to say something else, but then I thought it would be construed wrong, so I stopped. No, because I'm recording.
Plus 1 squared.
So it's x plus 1 squared, so it's x plus 1 and x plus 1, so I have to FOIL. So I'm going to write x times x is x squared. 1x, 1x, and 1. Over here, I just get rid of the radical, so 7x plus 15. Are you okay, Jordan? Oh, this looks fun.
You're not sleeping.
You are going so good.
Okay, Okay, I'll stop. We're gonna factor here, Jordan. Okay, so I FOILed this. We better combine like terms. Now I'm gonna try and save a little step here. I'm gonna combine these, but at the same time, I'm gonna subtract 7x over and subtract the 15 over. Okay, I won't. I'll stop. I'll undo that. Okay, I'll undo that. I won't try and do that. So I'll combine the 1x's, 2x plus 1. I decided not to do that. It was stressing a couple people out. I was going to combine these and move those two things over. You can if you would like.
She is not going to.
It was freaking some people out, so I stopped. So now I'm going to move these two things over. So I'm going to subtract 7x, I'm going to subtract 15. So I'm going to get x squared minus 5x minus 14 equals 0. Oh, this is more good practice to get us ready for that upcoming final exam.
Woohoo!
Oh, I can hardly wait for it. Because you know what that means?
You had to make this.
No! What does it mean if you're taking the final?
Your grade's bad.
Yeah, exactly. Thank you.
That's-
It means school's over! It means it's summer! It means you're graduating!
Man, you guys are
Man, are you not excited for that?
I'm worried about my grade more than that. I feel bad
Yeah,
for the person on the other side of the computer who's gonna watch with earbuds in right now.
Sorry if you're listening.
Miss Fox is gonna start screaming.
I know she's pretty quiet today.
You can hear doors slam when he's sitting down.
He's just constantly just.
But what?
thinking out.
The exam is 10% of your grade.
Now he's gonna go down.
Exactly.
Again.
So boost your grade right now. I am giving you lots of homework. You're not getting a big test. I made the test small. Instead of 100 points, it's only 60. You're getting a math reflection. That's an easy 25 points.
There you go.
Do your homework, do your homework, do your homework. Boost that grade up, and then the exam is not a problem.
You forgot one.
What?
All passes.
Hall passes, there you go.
Oh, yeah, that makes sense.
All right, we got to factor this. We're getting distracted. We got to factor. All right.
Gotta say.
All right, Jordan, you awake back there? All right. What do you know about signs? They are opposite. Factors of 14 that give me -5. Yep, so we need to do +2, -7. 2 minus 7 gives me -5.
Oh, you got me thinking about summer next
All right, we gotta say here in real life for a little bit. So x equals -2 and x equals 7. Well, guess what? We better check, and we got 2 answers to check. All right, so I'm gonna do my check over here. I'll put it in a different color so you can tell it's my check. I'm gonna rewrite this equation so it's a little bit easier to see where I'm checking. So I have my -2 first, so let's check that. So I'm gonna do -2 plus 1. Well, that's -1. Well, there's nothing wrong with -1, right? So that should equal the square root of 7 times -1 plus 15.
It's negative. It's a negative.
Thanks. -2. It's not a very good number in there. So 7 times -2 plus 15. All right, calculators. So you're going to hit the square root button. So second exponent button. And you're going to do, it gives you a parenthesis, doesn't it?
No, that's what.
That doesn't?
Wait.
I thought the regular square root gave you a
Oh,
parenthesis.
yeah, the
regular
regular
one,
one
yes.
The regular, just a square root does. All right, so you don't need to hit it here. So you're going to do 7 times -2 plus 15, close your parenthesis. What do you get? -1 equals 1. Does it?
No.
Not the last time I checked. Those are not equal. So I go back here. -2 is extraneous. I just put a line through it. Bryce, can you see?
Kind of.
So I put a line through -2. That's all I need to know that it's extraneous. Well, let's check 7. 7 plus 1 has to equal the square root of 7 times 7 plus 15. Well, 8 should equal whatever this is. So in my calculator, I'm going to pull it up. I'm going to do square root 7 times 7 plus 15, making sure all that's in parentheses. Let me know if you get 8.
Yep.
Logan says yes. Bree says yes. I'll trust him. So 7 is an answer. Usually, but not always, you get one of the 2 to work. But you can't have both work. You can't have both be extraneous. So just because you get the first one to be extraneous doesn't mean you can just assume the second one will work. You do have to check both of them. Are we okay on this? Thumbs up, thumbs down. Not a lot of feedback there. We will see if we have time. If we have time, we'll come back and do another one of these. But I want to get to another set of problems. The other type of problems we're going to do are equations with rational exponents. We'll definitely want our calculators for these. Equations with rational exponents. These we do not have to check. The directions, I think, say to check, but we do not have to check these. Again, I'm going to tell you which problems in the homework you have to check. Equations with rational exponents. So I've got x to the 2/3 equals 16. So I got to figure out how to get rid of that 2/3. So I'm going to leave it up to you to throw out some ideas.
Couldn't you change it like how we would do like the parentheses with the 2, like the 2 as an index, and then
So this is an idea. We could change the form. So which one's the index?
3.
We could square it. And we can do it in little steps. I agree with that. So let's do it this way, and then we'll see if we can come up with a shortcut way. So go ahead and change it. And maybe write it off, like do 2 different ways like I'm going to do here, because we're going to come up with a shortcut way. So if I've written it this way, I need to get rid of the squared first. How do I get rid of the squared? Not square, but I don't know if I heard something else over there, Chandler Bridge. Not square, but what? Not distribute. If something's squared, I need to square root it. So I need to square root both sides. So I get the cube root of x equals, well, what's the square root of 16? 4. Now I have the cube root. So I need to not cube root it, but cube it. And I think, again, it's the kind of thing we're probably doing it right on our paper. It's learning how to say it. Anyone know what 4 cubed is? It is 64. So we could do it this way every single time if we wanted. We could change the form and we could break it up. There's a way I could do it with exponents. I could take this and I could raise it. It's supposed to be a question mark. That is a poor question mark. Raise it to some power to eliminate that. What do I do if I have an exponent and an exponent? Distribute. So I multiply. If I'm distributing, I multiply. So my goal here is to figure out, what do I multiply by 2/3 to get 1?
3 over 2.
The reciprocal, 3/2. So if I use an exponent of 3/2, if I do it on the other side, I should get the same answer. So let's see if it works. So in your calculators, this is why a calculator is going to be so helpful. Do 16, make sure you use an exponent. Jordan, stay with me. This is where I tend to lose you. Do an exponent of 3/2. Make sure you use the fraction button. And it should match. So 64 sounds good to me. Oh, so that's what we can do. So we're going to use the reciprocal exponent. And reciprocal means you flip it. So you flip the exponent and you use that as the exponent. So we're going to try a couple more. Because oh man, that was a lot quicker than having to change it. So let's do x to the 3/5 equals 125. And if you're doing these problems and you get a decimal, you've done something wrong. They're going to give you ones, or I'm going to give you ones where it's going to come out nicely. So if you get a decimal, something went wrong. So if I have x to the 3/5, what exponent should I use? 5/3, good. The key is, make sure you use that as an exponent. Don't multiply, use it as an exponent. So in your calculator, plug it in as an exponent. 3,125 maybe?
Yeah.
It's a lot easier than having to change the form and go through the step by step. But worst case, you can always do that.
I mean, like when you forget your calculator on the day of the test.
True, which hopefully we don't do that.
'Cause I
But-
think that's happened a few
I
times.
think it has happened to some people.
We have warned you.
We have. Take that as you will. All right. Oh man, I jumped up a lot harder on this one. Good job. Just make sure you keep bringing it.
Oh, I'll keep it in the.
She's
book.
learned her lesson.
All right, we've got x plus 2 to the 3/4 minus 1 equals 7. So I jumped up a little bit on this one. Didn't warn you. Just bam, right there. Do you think I can distribute that 3/4? No, because of that addition. All right, so let's get this by itself first. Let's deal with that. So let's add the 1. So x plus 2, still to the 3/4, equals 8. So if I can't distribute that 3/4, I'm going to use an exponent. You can just use parentheses if you want. Technically, you're supposed to use brackets. what exponent should I use? Good. So reciprocal exponent, so exponent of 4/3. So you're gonna do 8 to the 4/3. 16. Well, then what's the only other thing we have to do? Subtract the 2. So x equals 14. This isn't bad. This one and I thought I had another one, but I'll make one. This one and one similar to it always throws people. So this one I've got 3x to the 3/2 equals 375. 3x to the 3/2 equals 375. Price, what do you think I do first?
Multiply with the reciprocal.
Before I gotta do something.
Haha, she got you.
Why don't you give us the answer, Isaiah?
125.
So I have to divide by 3. And so this is why I did this one, because it always gets confused by the other one I'm gonna give you. And so I'm so excited. I know what I have to do here. I wanna do it right away, but I gotta move that 3 first. So x to the 3/2 equals 125. Then worry about the reciprocal exponent. So 2/3. So you were right about using the exponent of 2/3. 25?
Yeah.
And then what if I had 2x in parentheses to the 2/5 equals 32?
Brackets.
And what, Isaiah?
5 seconds.
So here I first have to do, oh, this isn't gonna work out nicely. So we'll just do this first step, because I just told you things would work out nicely. That doesn't.
Liar.
I lied. Change it to 64 and it would.
I feel like it's not.
And we'll just make an arrow. Because we know the bells ring early, so I'm gonna go ahead and make sure you have the homework.
I can't believe you just figured that out.
Sorry, Maddie. Page 456, 20, 21, then 23 through 30. Then these two you need to check, 34 and 35. Those two are the only two that you will need to check on. And those are the two that you're gonna use FOIL on, I believe. But 34 and 35 are the only two you have to check. Oh, look at that perfect timing. Make sure you're paying attention instead of just doing that. Make sure you're paying attention instead of just doing that.